Education Session 2 is around synchronization. This is a process that's going to become a very important daily process for utilities. Synchronization is the process by which you provide MDMR with all of your CIS information, which will help them process and validate and store your meter read data properly. As we'll see in Session 3, MDMR processes and prepares your meter read data for billing at the time that it is received from the AMI vendors each morning. So it is critical that the MDMR have such items as your VE service code, your framing structure, and of course your SDP to meter relationships, so they know which premises the meter data belongs to. So synchronization is critical. Timing of synchronization is important to consider so that you can have MDMR properly prepared, I guess, to process your meter read data.
What is synchronization? Synchronization is the mechanism by which LDCs maintain data consistency between their systems and the MDMR. Why is synchronization required? The data is needed to support MDMR processes such as loading meter read data, VEE processing, framing, and billing quantities calculation. The LDC is responsible for maintaining accurate data and transmitting this data to the MDMR in a timely manner. If the master meter data is out of date, some MDMR processes may fail or produce invalid results.
When it comes to synchronization, if you submit changes to the MDMR that aren't very accurate, but MDMR updates it, you're responsible for what you send to MDMR, and that's what this slide is trying to tell you, is that if you follow the business processes and send them bad data, MDMR is just going to update bad data. So it's, the files is what the MDMR uses to update information, so what you put in the files should be accurate. It can be very impactful to your process, because if you, what the sync files are really doing is setting up, for the most part what they're doing is setting up the processing of meter read data. So if you've incorrectly synchronized which SDP a meter belongs to, that meter's consumption will be attributed to the wrong SDP.
There are two ways in which the LDC can update data in the MDMR. 1. Periodic audit synchronization, or PSync. 2. Incremental synchronization, or iSync. Mike Strano explains the difference between the two methods.
The big difference is that the incremental sync interface is what you use to process changes, and the periodic sync interface, you send the current state of all attributes for all SDPs.
The following elements are synchronized for each SDP: SDP data, meter data, account data, CT-PT multiplier data, which is the product of CT, PT, and meter multiplier, framing structure, VEE service data, measurement data, interested party data, and component SDP data. A sync file set is composed of multiple files. Mike Strano explains.
The sync files are actually a set of files. Here's a listing of the files. File 0 is what's called a manifest file. It tells the MDMR what to expect with this file set. So each of the files have sequence numbers. So the manifest file will tell MDMR this is file set number 42. And it's coming along with 2 file number 1s, 1 file number 2, 3 file number 3s, and so on. And the reason you might send more than one file is if the files become very large. For a PSync file with 40,000 SDPs, your asset data file is going to contain 40,000 records there of listing the meters. And if your AS2 client has file size limitations, it may become necessary for you to split up the files. I haven't seen that too often. For the most part, utilities aren't having to split up their files. But that's what the manifest file does. It describes to MDMR what files are coming along with this file set. Okay, file number 1 is asset data files. Describes the meters, for example. Meters are assets. COM modules are assets. File number 2 is the premise data file. So this is the file that you would submit the address in, some other premise-related information. File number 3, service agreement data file. This is your framing structure, commodity type. File number 4, parameter data files. So this would be something like the number of dials for a meter. So it's the additional attributes of an SDP or a meter. File number 5 is your relationship data file. So this is the file that you say a particular meter is related to an SDP. So it combines the different attributes. File number 6 is not used anymore. And file number 7 is that virtual meter information. This is a diagram that talks a little bit about sync file processing at MDMR. And I put it sort of into a business process type of a diagram. But so the CIS is going to generate these sync files and then move the files through the AS2 client down to the MDMR. If you submit files out of sequence, you will get what's called an IR10 report. And then because the files are as many as 7 files being submitted, and some of them can get large depending on the number of updates, it may take some time for MDMR to actually receive all the files. So if it takes them longer than an hour to receive the full file set, they will reject the file set. And that comes out on the IR10 as well. So there's what's called the maximum wait time of an hour and the file sequence that they check. And if any of those things are missed, they will give you an IR10 report describing how they've rejected the file. When the MDMR receives those files, the first thing they do is load these files into staging tables. So if you have any exceptions during the staging table loader process, you will get a report. It's called the IR14, and it talks about exceptions in that staging table loader. If the MDMR successfully loads your sync data into the staging table, then they will begin processing it. So if you get successful staging table loader tables, reports showing that it is successfully loaded, then you know that your, for example, your sync sequence number has been advanced. If you sent them file number 42 and you had a successful staging table loader report, you know that 42 has been processed and they will next time be expecting number 43. And then you'll start to look for the updates and exceptions report that tell you about the activity in that file. They will start to process updates. They move this data into the to be published tables and then report on it from there as they're loading it into the meter master data. So you get what's called the IR06 and the IR07 reports, updates and exceptions. Those reports are generated during this process of publishing data. Okay, so I'm going to talk from a high level about some threshold checks that happen during sync processing. This is one of the things that probably have changed a little bit in the newer versions. At the time that we generated these slides, back in version 2, this was the best understanding that ISO had of the e-meter sync processing as far as threshold checks. So I think it's okay to understand this from a high level, but if you really want the details, you need to kind of go to the technical specs around how these things work. For the most part, what you need to understand is that if it looks to the MDMR like too much has changed across your service territory, they stop, right? Because, like for example, in a P-Sync, if you don't submit an SDP in your P-Sync, they inactivate it. So if you ended up creating a broken P-Sync file that only had half of your USDPs, you wouldn't want the MDMR to inactivate half of your service territory. So there are checks in place that prevent things like that from happening. So the first check is to look for empty sync files. If it's a sync file, if it's an empty sync file, they don't process it. I don't even know why they put that there as a check. Check number 2, though, the next 3 checks are kind of similar in nature. They look for the first one is number of records. So if you have a sync file that successfully processes, and then the next sync file comes in with like half as many records, and we're thinking about P-Syncs here, right? Half as many records, they will reject that, so there's too much change here. The next 2 are updates and exceptions. So if they start processing a sync file and there's just way too many updates, they would say there must have been something wrong here. For example, a good example of this would be you send in a sync file where all of your meter numbers have leading zeros. And then you do maybe a CIS upgrade or something, and all of a sudden the next sync file goes out and every meter number has no leading zeros. Did I say that right, or did I say that right? One had leading zeros, one didn't. Well, even though the actual numbers, the significant digits there are the same, this looks to MDMR like you've changed every meter. And so you wouldn't want them to process that sync file, right? So that's the sort of thing that would be, that's an example of updates that you wouldn't want to actually have updated that MDMR. And then the last one is exceptions. So they start processing it, but it looks like everything is an exception, they'll stop processing it. So from a high level, it's a good thing to understand that there are checks and balances at MDMR that would stop bad things from happening in your sync processing.
After successful pre-validation, the following rules are applied in making updates to the MDMR. If the SDP exists in the sync file, but not the master meter data, the MDMR refreshes the existing SDP attributes in the MMD. The MDMR refreshes the existing SDP attributes in the MMD with the attributes and the relationships in the sync file. If an SDP exists in both the sync file and the MDMR, but the sync file contains an error, no updates are made to this SDP. If the SDP exists in the sync file, but not the MMD, the MDMR creates the SDP. A minimum set of SDP attributes must be included, and the USDP for that SDP must belong to the LDC that sent the file. If an SDP is not included in the sync file, but it does exist in the MDMR, or if a record is rejected because of data exceptions, then the MDMR will inactivate the SDP. Once the data is corrected in another sync file, the SDP is reactivated retroactively to the dates provided in the sync file. The Incomplete Synchronization File Set Report, or IR10, is received only when synchronization fails due to an incomplete file set or files received out of sequence. This is a critical report. Resolve all issues before proceeding. The Synchronization Staging Table Loader Exception Report, or IR14, indicates the status of the data load in the staging table. The code of 00 indicates successful loading. At the end of the sync process, the MDMR sends the following two reports to the LDC. These reports are produced anytime a sync completes successfully or unsuccessfully. The Synchronization Updates Report, or IR06, lists all updates that have been made to the master meter data. Only attributes that have changed are included. The Synchronization Exception Report, or IR07, provides a listing of records that have failed to update through a sync. When developing your business processes, consider that a wide range of processes affect synchronization data. Mike Strano explains.
If you look in the TIS, there's 14 scenarios that can result in synchronization data being generated. These are some of them, maybe all of them, split out according to typical departments in the utility, like metering. You could communicate meter changes, removals, new services, record modifications in metering, VEE, service code changes, or manual exceptions that you're trying to resolve at MDMR. AMCC type, once set, I don't think you ever change that for the most part. Census meters are collected by the census system. Billing, collection, service address modification, final billing of accounts. So you're ending an account relationship there. Actually, we've got a new service down in this swim lane. Bill code changes. That isn't actually in the TIS as something that goes in the sync files because bill codes don't. But if you've set your VE service code to be dependent on a bill rate code, then changing a bill rate code might, in fact, impact your sync data. Deleting accounts, route number changes, service status, so there's your disconnect, reconnect flags, VE service codes, framing structure. So all this stuff that you're changing at a utility affect records that go into a sync file and eventually get into an iSync file. It changes. This little decision box here, iSync before psync. For the most part, because you don't want to communicate any changes through a psync, when it comes time to process a psync, you always create an iSync immediately before that. Make sure your changes have been processed, and then you would move forward with your psync process.
The purpose of the periodic audit synchronization interface is to process a complete synchronization of the MDMR master directory with the LDC data sources. The psync is used to create SDP objects and all related data attributes and relationships in the MDMR. This is a one-time activity to be completed for every new universal SDP ID that has been assigned. If an SDP that already exists in the MDMR is excluded from the psync file, it is set to inactive. Only current data is included in the psync. If data has changed from what exists in the MMD, the sync process will make the updates, and if necessary, the MDMR will infer end dates of existing relationships based on start dates for the new relationships provided in the sync file. The psync can also be used as an audit of SDP data.
Current relationships are all that are sent in a psync file. You just send in the active meter, the date that it started, and there's no end dates in psync files. It's all the current relationship. This is sort of what used to happen if you tried to process changes through a psync file. For example, if you processed a meter change in your CIS last Wednesday, then the end date of the old meter would have been last Wednesday, and the start date of that new meter would have been last Wednesday. If you didn't send that in an iSync file, but sent a psync file today, the psync file would say, this is the new meter, this is the meter, and it started last Wednesday. And that's all that you would send. And so they would say, well, this isn't the meter that we have here. We have this other meter associated with this premise. So they would see a change there. And what this statement here, inferring the end date, is telling is that if they had seen a relationship that was different than what they have, they would infer an end date. And the date that they use is the file creation time of the psync. So if we sent a psync in at 2:11 today, and they saw that there was an old relationship there, they would end that old relationship as of 2:11 today and start up the new relationship. So this is not what you would want to happen anyways, right? Because in that case, in that example, the meter change happened last Wednesday. So you wouldn't want the end date of that old meter to be today.
Psync frequency and timing. Psync files may be submitted up to once a day. Timing and frequency are determined jointly between ISO and the LDC. Psync files are not intended to support regular daily updates to the MDMR. The iSync is the primary method of maintaining SDP attributes and relationships in the MDMR on an ongoing basis. The purpose of the iSync is to synchronize the MDMR as specific SDP-related data and/or relationships change. The iSync contains only those SDPs whose attributes have changed since the last request. The iSync interface is used to submit a subset of attributes. Dependent on the type of transaction, for example, a meter change or an account change, it supports partial updates, for example, one or more attributes or one or more SDPs. The interface can also be used to initially load one or more SDPs with all attributes. iSync frequency and timing. Incremental synchronization files are expected from each LDC once per day. The LDC can also send multiple iSync files in a day. iSync files received by 4 p.m. will be processed by midnight. The changes will have been updated prior to meter data arriving the following morning. Mike Strano walks you through a sample iSync business process.
Sync operator again starts the process. Is this a manually initiated process each day, or is it automated? It can be automated. I think that initially you probably want to at least handhold the transport of these files down to the MDMR so that you can stop them on the way out and learn about the files. So, when I create a meter change, this is what my sync files look like. When I create a V service code change, this is what they look like. So if you automatically submit them right out of CIS, you never get that opportunity to look at them before they go. So I think you want to at least have this partially manual in the beginning. So what I just walked through there, if you had it automated, the automated piece of that would be the initiation, the triggering of the process. And so if you had that timed each day, it would be automatically generated, and then it would be fed into the AS2, which could be either automated or manual. Through testing, though, you're going to want to be able to manually even start the process running, because you're going to want to do this several times a day to do lots of testing. So the logic then, once it gets down to the CIS, is has there been a change at the USDP since the last time I synchronized. If nothing has changed at the account level, for all of those things that we just talked about there, meter change, account change, all that stuff, then nothing goes in the sync file for an async. It contains only changes. Okay? So if there has been a change, then file 4000 is built. So 3000 was psync, 4000 is isync. And these isync files would then be provided to your AS2, which would then provide copies to all of your downstream partners, MDMR, AMI, and ODS. And the only one that provides reports back would be the MDMR. You'd get possibly an IR10, we hope not, but IR14, 6, and 7. One of the things that we reference on the diagrams and we'll continue to talk about is this concept of IR06 being the trigger for ODS to resubmit data. Thinking about timing for a second, for meter change, say, if you've removed a meter from an SDP, that meter is no longer associated with that SDP, and a new one is. So it's the new one that you need to start receiving meter data for. You can't submit meter data to the MDMR though until they've updated that sync relationship. So the only positive confirmation that the MDMR is ready to receive meter data for a new meter is communicated through the IR06. It's an update from the MDMR that says, hey, I've got this new meter to SDP relationship here. So we keep pushing for the ODS systems to use the IR06 as a trigger for data resubmission. Once the MDMR gives you a report that says these relationships have been updated, then you can resubmit data for those relationships.
This concludes the Synchronization Interface module. In Session 3, Utilysys walks you through the next MDMR process, daily reads processes.